Helen Porter was staring at a crack that shouldn't exist when she realized her handmade piece of scrap metal might save more lives than any bomb dropped from a B-17. The engineers called it stupid. The factory bosses wanted to scrap it. But when test pilots took that modified flying fortress back into the sky, something impossible happened. The engines stopped tearing themselves apart mid-flight. In a war where bomber crews faced a 1 in 4 chance of never coming home, this toolmaker's ridiculous-looking clamp was about to change everything. What started as an unauthorized repair in a forgotten corner of an aircraft hangar would become one of the most quietly crucial innovations of World War II. Before we carry on, please hit the subscribe button to make my day and let me know where you are watching from in the comments. The morning of March 14, 1943, began like any other at Wright Field's repair depot outside Dayton, Ohio. Helen Porter clocked in at 6:30, her coveralls still smelling of machine oil from yesterday's shift, her hands already reaching for the toolbox she'd carried from station to station for the past 8 months. At 32 years old, she was older than most of the women working the factory floor, a detail that earned her both respect and isolation in equal measure. She had learned her trade not in the rush of wartime necessity, but through years of quiet work in her father's automotive shop, back when a woman with grease under her fingernails was considered an oddity rather than a patriotic necessity. The hangar stretched before her like a cathedral of broken birds. B-17 flying fortresses in various states of damage lined up in rows, some missing entire tail sections, others with engines torn away like rotten teeth. The smell of aviation fuel mixed with hydraulic fluid and the sharp tang of welding work created an atmosphere that most found oppressive, but Helen had long ago learned to find comfort in the scent of mechanical problems waiting to be solved. She walked past crews working on a bomber that had limped back from a raid over Bremen, its fuselage stitched with flak holes that told stories of near misses and lucky breaks. The men working on it barely glanced her way, which suited her fine. Her assignment for the day sat in Bay 7, a B-17F that had been forced to make an emergency landing in England after losing 2 engines over the North Sea. The official report listed combat damage as the cause, but Helen had learned to read between the lines of maintenance logs. She pulled the clipboard from its hook on the wall and scanned the technical notes, her eyes catching on a phrase that had become all too familiar in recent weeks. Catastrophic engine mount failure, structural fatigue, recommend full replacement of damaged components. It was the 3rd such report she had seen in as many days, and something about the pattern gnawed at her attention, like a splinter working its way deeper. She climbed the ladder to the bomber's port wing, her boots finding familiar holds on the access panels. The engine nacelle had been opened already, the massive Wright R-1820 Cyclone engine partially dismantled to reveal the mounting structure beneath. Helen pulled her flashlight from her belt and directed the beam into the shadows of the mount assembly. And that's when she saw it. A crack no thicker than a human hair, spiderwebbed across the forward mounting bracket, not from the combat damage or even from obvious stress, but from something more insidious. She ran her finger along the metal surface, feeling the subtle texture change where crystalline fatigue had weakened the structure at a molecular level. The mount itself was a marvel of engineering, a carefully designed assembly of bolts and brackets that secured a 2,000-pound engine to an airframe traveling at 200 miles per hour through hostile skies. Every calculation had gone into its design, stress loads and vibration frequencies and safety factors all balanced against the demands of weight and manufacturability. Yet here it was, failing not from any single catastrophic force, but from the accumulated insult of thousands of hours of operation, the endless drumming of 9-cylinder radial engines shaking the very bones of the aircraft until something had to give. Helen descended the ladder and walked to the next bay, where another B-17 sat awaiting inspection. She found the same telltale cracks in its engine mounts, hidden in shadows where casual inspection might miss them. A 3rd aircraft revealed similar damage, and a 4th. By lunchtime, she had documented failure points in 6 different bombers, each crack appearing in roughly the same location on the forward mounting bracket. The pattern was undeniable and more worrying. It suggested a fundamental design flaw that affected not just the handful of damaged aircraft in this hangar, but potentially every B-17 in the American bomber fleet. She brought her findings to Jack Harrigan, the shift supervisor, a gruff former airline mechanic who had been fixing aircraft since before Helen was born. He listened to her explanation while eating a sandwich that looked like it had been assembled in poor light, nodding occasionally, but without much enthusiasm. When she finished, he wiped mustard from his chin and fixed her with a look that was equal parts tired and unconvinced. "Porter, we've got 300 damaged bombers moving through this depot every month," he said, his voice carrying the weight of a man who had heard every theory and complaint the job could generate. "You're telling me you want me to ground inspections and start pulling mount assemblies on aircraft that haven't shown problems yet? Do you understand what that would do to our throughput numbers?" Helen held her ground, though she felt the familiar frustration of being dismissed building in her chest. "I'm telling you that we're sending aircraft back into combat with a structural weakness that's going to kill crews. These cracks don't appear in the damage reports because the engines haven't separated yet, but it's only a matter of time." Harrigan sighed and set down his sandwich. "Look, I'll put it in a report, send it up the chain. But you need to understand that changing a design specification on an aircraft as critical as the B-17 requires approval from people way above my pay grade. It means wind tunnel tests and engineering reviews and probably 6 months of bureaucratic paperwork. In the meantime, we've got a war to fight and bombers to fix. So, unless you've got a solution that doesn't require shutting down production, I need you back on the floor doing your actual job." She returned to Base 7, feeling the weight of futility that came from spotting a problem that everyone else seemed content to ignore. But as she worked through the afternoon, removing damaged components and preparing the mount for replacement parts, an idea began to take shape in her mind. The crack had formed because the mounting bracket was absorbing all the vibration load at a single point, creating a stress concentration that eventually exceeded the metal's fatigue limit. What if, instead of redesigning the entire assembly, she could simply distribute that load across a wider area? The solution didn't require exotic materials or complex manufacturing, just a way to clamp the existing mount structure and provide additional support at the critical failure point. That evening, after her shift ended and most of the other workers had gone home, Helen returned to Base 7 with a cart full of scrap metal she had collected from the cutting room floor. Under the harsh glare of work lights, she began to fabricate a prototype brace using nothing but hand tools and a welder she had borrowed from the structural repair section. The design was crude, little more than a U-shaped channel of thick steel plate that would fit around the existing mount and bolt directly to the engine nacelle frame. It looked, even to her own eyes, like something a child might build from an erector set, all exposed bolt heads and rough welds that would make any engineer wince. She worked through the night, measuring and cutting and grinding away imperfections until her arms ached and her eyes burned from staring at molten metal. By 3 a.m, she had something that might work, or might simply add dead weight to an already overloaded aircraft. There was only one way to find out. She installed the brace on the damaged mount in Base 7, carefully torquing each bolt to specification and checking the alignment with levels and straight edges. The clamp wrapped around the forward mounting bracket like a mechanical embrace, ugly but solid, transferring load from the weakened crack point to the stronger surrounding structure. When Harrigan arrived the next morning and saw what she had done, his reaction was everything Helen had expected and dreaded. He stood beneath the bomber's wing, staring up at the improvised clamp with an expression that cycled through confusion, disbelief, and finally something approaching anger. "Porter, what in God's name is that thing?" he asked, his voice tight with the kind of controlled fury that supervisors reserve for subordinates who had crossed an unspoken line. Helen climbed down from the wing, wiping her hands on a rag that was already black with grease. "It's a vibration damping clamp. It distributes the stress load across the entire mount assembly instead of concentrating it at the bracket point. I think it'll prevent the kind of fatigue cracking we've been seeing." "You think," Harrigan repeated, investing the words with heavy skepticism. "You installed an unauthorized modification to a United States Army Air Forces bomber based on what you think might work. Do you have any idea how many regulations you just violated? Do you understand that this aircraft is supposed to be cleared for return to service today?" She met his gaze without flinching. "I understand that if we send it back with a cracked mount, there's a decent chance the engine will separate at altitude. Maybe over friendly territory where the crew can bail out. Maybe over the North Sea where they'll drown in the cold. But either way, 10 men will be dead because we knew there was a problem and did nothing." The argument might have escalated further, but they were interrupted by the arrival of Captain Raymond Vickers, an Army Air Force's engineering officer who made regular inspections of the depot's work. Vickers was young for his rank, barely 30, with the kind of technical education that came from MIT classrooms rather than hangar floors. He had a reputation for being both brilliant and insufferably pedantic, the sort of man who could cite stress equations from memory, but had never turned a wrench in his life. When he saw the clamp, his reaction was immediate and visceral. "Who authorized this modification?" he demanded, his voice carrying across the hangar floor and drawing the attention of nearby work crews. "This is completely outside specification. It hasn't been tested, it hasn't been approved, and it looks absolutely stupid." Helen stepped forward before Harrigan could respond. "I built it. Nobody authorized it. But before you order it removed, maybe you should look at these." She handed him the folder of documentation she had prepared, showing the crack patterns she had found, and her analysis of the failure mechanism. Vickers took the folder reluctantly, his expression making it clear that he considered this an annoying interruption to his scheduled inspection routine. He read through her notes in silence, his frown deepening with each page. When he finished, he looked up at the clamp again, and Helen thought she detected a slight softening in his expression, though it might have been wishful thinking. "Your analysis of the failure mode is actually quite good," he admitted grudgingly. "The crack initiation point you've identified matches what we'd expect from high cycle fatigue under vibrational loading. But your solution, if we can even call it that, is completely unscientific. You've essentially welded a piece of scrap metal to a precision-engineered component without any calculation of how it will affect the system's dynamic response." "I calculated it," Helen said quietly. "The mass of the clamp is approximately 12 pounds, which adds less than 0.6% to the total engine assembly weight. The additional moment of inertia is negligible, but by clamping the mount at the stress concentration point, we create a mechanical advantage that should reduce peak strain by approximately 40%, assuming my estimates of the vibration amplitude are correct." Vickers stared at her, as if she had suddenly started speaking ancient Greek. "You did stress calculations for this thing? I can show you my work if you want. It's basic beam theory. Nothing complicated. My father used to make me calculate deflections for suspension components when I was 16. Same principles apply here, just different loading conditions." For a long moment, Vickers said nothing. He walked around the aircraft, examining the clamp from different angles, occasionally reaching up to test the tightness of a bolt or check the weld quality. Finally, he turned back to Helen and Harrigan with a decision written on his face. "I want this aircraft ground tested before it goes anywhere. Full engine run at operational power settings, with vibration sensors mounted at the failure points. If your clamp performs as you claim, we'll send the data to Wright-Patterson for evaluation. If it doesn't, you're going to personally remove every trace of this modification and explain to Colonel Bradshaw why we had to delay the aircraft's return to service. Are we clear?" The ground tests took place 2 days later on the depot's engine run-up stand, a reinforced concrete pad at the edge of the field, where damaged aircraft could be safely tested at full power without the risk of an uncontrolled takeoff. Helen stood behind a blast barrier with Vickers and a team of engineers, watching as the B-17's engines roared to life one by one. The test protocol called for running each engine through its full power range, while sophisticated instruments measured vibration levels at dozens of points across the mount assembly. The data would show whether her clamp actually reduced stress or simply created new problems of its own. The engines climbed to full power, their combined thrust pushing against the tie-down chains with enough force to make the entire aircraft strain forward against its restraints. Helen felt the noise as a physical pressure against her chest, the distinctive roar of Wright cyclones at maximum output blending into a sound that was less heard than experienced. Through binoculars, she watched the clamp closely, looking for any sign of movement or failure, but the crude assembly held steady while the instruments recorded their data in careful detail. After 30 minutes of testing at various power settings, the engines were shut down and the data was compiled. Vickers reviewed the results with his team, occasionally pointing at graphs and making notes in a leather-bound journal. Helen waited, trying to read meaning in their expressions and failing. Finally, Vickers approached her with the kind of careful neutrality that could mean either good news delivered modestly or bad news delivered gently. Your clamp reduced peak vibration amplitude at the mount bracket by 43%, he said, consulting his notes. It also shifted the dominant vibration frequency away from the structure's resonant point, which should significantly reduce fatigue accumulation. I'm not entirely sure how you managed to achieve this with what is essentially a random piece of bent metal, but the data doesn't lie. This modification appears to be effective. Helen felt something release in her chest, a tension she hadn't fully realized she was carrying. So, what happens now? Vickers closed his journal and looked at her with an expression that was hard to read. Now, I write a report recommending immediate testing of your design under combat conditions. If it performs well in operational use, we'll need to figure out how to manufacture it at scale and retrofit the existing fleet. That means convincing a lot of people who are going to be very skeptical about taking engineering advice from a civilian toolmaker working unauthorized overtime. It's not going to be easy. But Vickers proved better than his word. Within a week, 3 B-17s equipped with Helen's clamps were cleared for combat operations, flying missions over occupied France while engineers on the ground monitored their performance through maintenance reports and crew debriefs. The results were remarkable. Where unmodified aircraft were experiencing engine mount failures at a rate of approximately 6% per 100 missions, the modified bombers showed 0 failures across their first 20 sorties. The clamps were doing exactly what Helen had predicted, distributing stress and damping vibrations in a way that allowed the mounts to survive conditions that would have previously caused catastrophic failure. Word spread through unofficial channels the way important information always does in wartime. Maintenance crews began requesting the clamps for their aircraft. Squadron commanders asked when the modification would be available for their groups. And somewhere in the bureaucratic machinery of the Army Air Forces, decisions were being made about production and distribution. Helen found herself pulled from regular depot work and assigned to a small team focused entirely on refining her design for mass production. The crude hand-welded prototype gave way to a stamped steel version that could be produced by the thousands in existing manufacturing facilities. But the basic principle remained unchanged. By June of 1943, the clamp had been officially designated as Modification 378-6 and was being installed on new aircraft coming off the assembly line. By August, retrofit kits were being distributed to bomber groups across England and North Africa. And by the end of the year, analysis of maintenance records showed that engine separation incidents had declined by nearly 48% across the entire B-17 fleet. A reduction that translated into hundreds of crew members who came home instead of dying over hostile territory. Helen returned to regular depot work, though her role had changed in subtle ways. Engineers who had previously dismissed her now sought her input on problems they were facing. Supervisors gave her latitude to investigate issues that caught her attention, and gradually, quietly, she became known as someone who could spot problems that others missed. The toolmaker who looked at aircraft with an eye not just for what was broken, but for what might break under conditions nobody had yet imagined. She never received a medal or formal recognition for her work. The clamp was attributed in official documents to the engineering team at Wright-Patterson, with her name appearing only as a footnote in technical reports that few people would ever read. But she received something more valuable in the form of letters from bomber crews, smuggled to her through informal networks of mechanics and ground crew who knew the story behind Modification 378-6. The letters were simple, often just a few sentences thanking her for what she had done, but they carried weight beyond their words. One letter in particular stayed with her long after the war ended. It came from a pilot named Robert Casey, written in pencil on paper that had been folded and refolded so many times it was beginning to tear along the creases. He described a mission over Schweinfurt, where his No. 3 engine had taken flak damage that would normally have torn it loose from its mounts. The clamp had held, keeping the engine attached long enough for him to nurse the bomber back to England, where all 10 members of his crew walked away alive. "I don't know who you are," he had written, "but you saved our lives with a piece of metal that somebody told me looked stupid. Thank you for being stupid in all the right ways." The war ground on, each day bringing news of battles won and lost, of cities bombed and territory gained or surrendered. The B-17s continued to fly their missions, carrying their deadly cargo into the heart of Nazi Germany, while Helen's clamp quietly did its job, holding engines in place through flak and fighter attacks and the brutal vibrations of maximum power operations. It was not glamorous work, and it did not appear in newspaper headlines or newsreel footage, but it was work that mattered, and that was enough. In the evenings after her shifts ended, Helen sometimes walked out to the edge of the airfield and watched the bombers take off for their training flights, their engines roaring with a power that shook the ground beneath her feet. She thought about the crews inside those aircraft, young men barely out of high school who would soon be facing death over Europe. She thought about the thousands of small decisions and innovations that kept those men alive, from the armor plate beneath their seats to the self-sealing fuel tanks in their wings. And she thought about her clamp, that stupid-looking piece of bent metal that had somehow become part of the intricate machinery of survival. As 1944 turned into 1945 and the war in Europe entered its final phase, the bomber offensive reached its peak intensity. Thousands of aircraft filled the skies over Germany, dropping their payloads on factories and rail yards and military installations in a campaign of destruction that was terrible in its scale and necessity. The losses were staggering, entire squadrons wiped out in single missions. But the mission continued because there was no alternative, because stopping meant giving victory to an enemy whose evil demanded total defeat. Helen followed the progress of the war through official reports and unofficial gossip, tracking the advance of Allied armies across France and into Germany itself. She knew that her clamp was playing a role in that advance, one tiny piece of a vast and complex machine that was slowly, brutally grinding the Third Reich into dust. And she knew that when the war finally ended, her contribution would be forgotten by everyone except the men whose lives it had saved, which was a kind of immortality that no medal could provide. The letter came on a Tuesday in April, just 3 weeks before Germany's surrender. It was typed on official Army Air Forces stationery and signed by a brigadier general whose name Helen didn't recognize. The letter informed her that analysis of combat loss records had confirmed the effectiveness of Modification 378-6, and that her innovation had been credited with preventing an estimated 473 engine separation incidents during combat operations. Assuming a crew of 10 per aircraft, that meant her clamp had potentially saved over 4,000 lives, a number so large it felt abstract and unreal. But the general's letter went further. It announced that Helen was being awarded the Medal for Merit, a civilian decoration created specifically to recognize exceptional service in support of the war effort. The presentation would take place at Wright Field in 3 weeks, with full military honors and press coverage. Helen read the letter twice, trying to reconcile the formal language with the reality of what she had done, welding a piece of scrap metal in the middle of the night because nobody else seemed to care about the problem she had found. The award ceremony was held on a brilliant May morning, with spring flowers blooming around the base headquarters, and a crowd of military officers and civilian workers gathered to witness the presentation. Helen stood at attention in a new dress she had bought specifically for the occasion, feeling awkward and exposed in a way that greasy coveralls had never made her feel. The general pinned the medal to her lapel and shook her hand while photographers captured the moment for posterity. Reporters asked her questions about innovation and determination, and what it meant to contribute to the war effort as a woman in a male-dominated field. She answered as best she could, but the words felt inadequate to describe the real experience of what she had done. How could she explain the frustration of being ignored when she tried to report a problem through official channels? How could she convey the quiet satisfaction of solving a puzzle that nobody else thought could be solved? How could she make people understand that her clamp was not the result of inspiration or genius, but simply the product of paying attention, of caring enough about the lives of strangers to spend her own time and effort on a problem that everyone else had accepted as unsolvable? When the ceremony ended and the crowd dispersed, Helen returned to the hangar where she had first spotted those fatigue cracks in the engine mounts. The B-17 that had received her prototype clamp was long gone, returned to combat, and eventually lost over Berlin in the final months of the war. But other bombers filled the bay now, damaged aircraft waiting for repair, each one representing a crew that had survived long enough to bring their plane home. She walked among them, running her hands along scarred metal and patched holes, reading the history of air combat in every dent and tear. A young mechanic approached her, barely 20 years old, with oil stains on his uniform and a question in his eyes. "Ma'am, are you the one who invented that engine clamp? The one they've been putting on all the forts?" Helen nodded. "I am, though invented is probably too strong a word. I just saw a problem and tried to fix it." The mechanic smiled, a gesture that transformed his grease-smudged face. "My brother flies B-17s with the 398th. He wrote me about how your clamp saved his plane when they took Flak over Magdeburg. Engine got hit bad, but it stayed attached long enough for them to make it back. He wanted me to thank you if I ever met you." They talked for a few minutes, the mechanic describing his brother's experiences, while Helen listened with the kind of attention that made people feel heard. When he left, she remained in the hangar, surrounded by wounded aircraft and the tools of her trade. The metal in her pocket felt heavy, a tangible weight that represented all the invisible work that made survival possible in wartime. She thought about all the other Helen Porters out there, civilian workers whose names would never appear in history books, but whose contributions were woven into every aspect of the war effort. The women who assembled ammunition and built tanks and operated radios and did 1,000 other jobs that kept the military machine functioning. They were the hidden infrastructure of victory, unsung and largely unremembered, but absolutely essential. The war ended 3 weeks later when Germany surrendered unconditionally. Helen stood with thousands of other workers at Wright Field and listened to the announcement over loudspeakers, feeling a complex mix of relief and sadness that defied easy description. The bombers would stop flying now, at least in Europe. The men who survived would come home, and slowly, gradually, the machinery of war would convert back to the machinery of peace. Her clamp would become a footnote in technical manuals, a small modification to an aircraft that would itself soon be obsolete, replaced by jets and missiles and technologies that existed only in imagination during those desperate years when survival itself felt like victory. She kept working at the depot through the summer, helping to process the flood of aircraft returning from overseas bases, planes that had survived the war but bore the scars of their service in every rivet and panel. By September, the workforce was being reduced as contracts ended and military spending declined. Helen received notice that her position would be eliminated at the end of the month, a polite letter thanking her for her service and wishing her well in civilian life. She wasn't surprised. The war had created temporary opportunities for women in industries that would soon close their doors once male veterans returned to reclaim their jobs. On her last day, she took one final walk through the hangar where she had spent so many hours during the war. Most of the bombers were gone now, either scrapped for raw materials or placed in storage against the possibility of future conflict. The space felt empty and echoing, a cathedral without worshippers. She stood beneath the wing of the last B-17 remaining in the bay and looked up at the engine mount where her clamp had once been installed, now removed and replaced with standard hardware as the aircraft was prepared for storage. Helen thought about all the crews who had flown an aircraft with her modification, the thousands of men who had returned home because an engine had stayed attached instead of tearing loose at the worst possible moment. She thought about the letters she had received, carefully preserved in a box at home, testimonies from people whose lives had been touched by her work in ways both profound and invisible. And she thought about the strange arbitrariness of recognition, how some contributions were celebrated while others were forgotten, not because they mattered less, but because they fit less neatly into narratives of heroism and sacrifice. The years after the war brought their own challenges and changes. Helen eventually found work at a small machine shop in Dayton, using her skills to manufacture components for the peacetime economy. She married late, to a kind man who had lost a leg at Normandy and who understood the weight of unspoken memories. They built a quiet life together, marked not by grand achievements but by the accumulation of small satisfactions, a life that felt earned rather than given. She never spoke much about her time at Wright Field, not because the memories were painful, but because they felt private, a chapter of her life that belonged to a particular moment that could never be fully explained to those who hadn't lived through it. Decades later, long after Helen had retired and the B-17s had become museum pieces, a researcher studying World War II maintenance innovations discovered documentation of Modification 378-6. Intrigued by the unusual story of its development, he tracked down surviving records and eventually found Helen, by then in her 80s, and living in a retirement community outside Dayton. He interviewed her extensively, recording her memories and collecting the letters she had saved from bomber crews. His resulting article in a journal of military history brought her story to light for the first time since the war. The article prompted a small flurry of recognition. A local newspaper ran a feature story. The Air Force Museum invited her to a ceremony honoring civilian contributors to air power. She received letters from the children and grandchildren of men who had flown with her clamp protecting their engines, people who wanted to thank her for giving them the gift of a parent or grandparent who had survived the war. The attention was gratifying in its way, but Helen found herself slightly bemused by the sudden interest in something she had done so long ago, a moment of her life that had been over for more than 50 years. What stayed with her most strongly was not the recognition or the gratitude, valuable as those things were, but the memory of that night when she had worked alone in the hangar, building something crude and imperfect because the perfect solution was impossible and doing nothing was unacceptable. That moment had taught her something fundamental about the nature of problems and solutions, about the gap between what engineers designed in ideal conditions and what actually worked in the messy reality of operational use. Her clamp had been called stupid because it didn't look like what people expected an engineering solution to look like. It was rough where it should have been smooth, improvised where it should have been calculated, unauthorized where it should have been approved. But it had worked, and in working it had saved lives, and that was the only metric that truly mattered. Helen understood that her contribution was just one tiny piece of a vast collective effort, that thousands of other people had made similar contributions that together created the margin between victory and defeat. But she also understood that every one of those contributions mattered, that the bomber offensive which helped win the war succeeded not just because of grand strategy and overwhelming force, but because of countless small improvements and innovations made by people whose names would never be remembered. Helen Porter died on a winter morning in 2008, surrounded by family in a hospice room that looked out over the same Ohio fields where she had once watched B-17s take flight. She was 97 years old and had lived long enough to see her grandchildren grow up, to witness the end of the Cold War and the beginning of a new century, to watch as the world she had helped save transformed into something unrecognizable from the world of her youth. Her obituary in the Dayton newspaper mentioned her war service in a single sentence, noting that she had worked at Wright Field and received the Medal for Merit for contributions to bomber safety. But the real measure of her life was not captured in newspaper columns or official citations. It lived instead in the continuation of lives that might otherwise have ended, in the families that existed because bomber crews had made it home, in the ripples of consequence that spread outward from that single night when a toolmaker decided that a stupid-looking clamp was better than accepting preventable death. Those consequences were invisible and unmeasurable, woven into the fabric of history in ways that could never be fully traced or acknowledged, but they were real nonetheless. The B-17s are museum pieces now, their engines silent and their bomb bays empty. Artifacts of a vanished age when industrial warfare consumed entire nations, and the outcome hung in the balance of 1,000 technical decisions. Visitors walk beneath their wings and marvel at their size, their complexity, their testimony to American manufacturing prowess. They read plaques about bomb loads and operational ranges and the number of missions flown. But they don't see the modifications and improvements that kept those aircraft flying, the accumulated wisdom of mechanics and engineers and toolmakers who solved problems one at a time until the sum of their solutions added up to victory. Somewhere in an archive at Wright-Patterson Air Force Base, there is a technical manual that includes a brief description of Modification 378-6, a paragraph of dry engineering language that explains how the clamp should be installed and why it improves engine mount durability. Helen Porter's name appears in a footnote at the bottom of the page, a small acknowledgement of her role in its development. It is not much of a memorial, barely sufficient to preserve the memory of what she accomplished. But perhaps that is appropriate for a woman who never sought recognition, who built her clamp not for glory, but because she saw a problem that needed solving and had the skill and determination to solve it. The real memorial exists not in archives or museums, but in the descendants of those bomber crews who came home because an engine stayed attached when it should have failed. They are teachers and doctors and truck drivers and everything else, living ordinary lives that feel utterly unremarkable until you remember that none of them would exist if not for a toolmaker's stubborn refusal to accept that nothing could be done. That is the quiet heroism of people like Helen Porter, not dramatic or photogenic or easily commemorated, but profound in its consequences and deserving of remembrance nonetheless. In the end, her story is not really about a clamp or an aircraft or even a war. It is about the gap between how things are supposed to work and how they actually work, and about the people who live in that gap and make survival possible through improvisation and determination, and a willingness to be called stupid by those who think solutions should always look elegant and authorized. It is a story worth remembering, not because it is unique, but because it represents thousands of similar stories, contributions made by people whose names we will never know, but whose work shaped the world we inherited. And perhaps that is the most important memorial of all. Not the preservation of individual recognition, but the acknowledgement that behind every grand historical narrative, there are countless small stories of people who saw problems and fixed them, who built stupid-looking solutions that worked, who quietly saved lives without expecting thanks or remembrance, and who did so simply because it was the right thing to do, and they had the skill to do it.